Hello champs, welcome to this section of the questions and answers. These questions are asked in between the lessons, precisely in page number 6, 10 and 13. So let us try to answer them one by one. Why should a magnesium ribbon be cleaned before burning in air? This is interesting because even before we use the magnesium ribbon for the reaction of burning it in Bunsen burner, that magnesium ribbon might have got exposed to air and in reaction with the oxygen in atmosphere it might have formed a layer of magnesium oxide. That magnesium oxide will slow down the reaction of magnesium burning in oxygen. So what we need to do is we need to clean the surface of any magnesium oxide that is formed earlier. So all we need to do is take a salt paper, rub on the magnesium ribbon so that the magnesium oxide gets removed and the magnesium underneath is exposed. Now we can burn this magnesium ribbon in the Bunsen burner and the burning process takes place easily. That is the reason we have to clean the magnesium ribbon. Write a balanced equation for the chemical reactions. Okay, we have three such. Hydrogen plus chlorine gives hydrogen chloride combination. Barium chloride and aluminium sulfate gives barium sulfate and aluminium chloride double displacement. Sodium plus water gives sodium hydroxide and hydrogen. That's fine. So all these reactions are already balanced and we have discussed about balancing the reactions. So try them. Let's go to the next. The solutions of barium chloride and sodium sulfate gives barium sulfate and sodium chloride in aqueous form. Okay, that's great. And this is an example of the double displacement again. And NaOH plus HCl gives NaCl plus H2O. Fine. Is it balanced? Yes. There are two hydrogen, one in the hydroxide group and the other in the hydrochloric acid. Okay, so let's move to the next section. A solution of substance X is used for whitewashing. Now, that is simple, it's quicklime. And when quicklime reacts with water, we get slaked lime. We have already discussed about these reactions in the earlier section, in our combination reaction section. So just refer to that and you will understand this easily. And why is the amount of gas collected in the test tubes in activity 1.7 double the amount collected in the other? Name the gas. Okay, this is interesting. Activity 1.7 is nothing but electrolysis of water. When we pass electricity through water, we get two types of ions. One is the H plus, positive cations, hydrogen cations, which are positively charged, and they move towards the negatively charged cathode. And the negatively charged oxygen ions, and they are attracted by the positively charged electrode, the anode. But when you balance this equation, the base equation is H2O giving H2 plus O2. That is simple. When you balance it, you will find that in the product side, but when you balance this equation, you will find that two molecules of water, it goes to give two molecules of hydrogen and one molecule of oxygen. That is the reason the amount of gas collected at the cathode is double that of the amount of gas that is collected at the anode, and the gas is hydrogen. It is because in the product side, two molecules of hydrogen is produced and only one molecule of oxygen is produced. Okay. So let's move to the next. Why does the color of copper sulfate solution change when iron nail is dipped in it? The color of copper sulfate is blue. When iron is dipped in copper sulfate solution, iron reacts with copper sulfate to form iron sulfate. This is a displacement reaction where copper is displaced from the copper sulfate. So, when the amount of copper sulfate in the solution is going down due to this reaction, the blue color also fades. Because copper sulfate, as it goes as its volume diminishes, the color also fades. You have only iron sulfate and copper is displaced. So the next reaction is an example of double displacement, where lead nitrate reacts with hydrochloric acid to give lead chloride and nitric acid. It's a very interesting reaction, because we are going to see that in a different perspective. What is the only metal here? The only metal I find here is lead, and lead has a valency of 2. Now what do we understand? It has a valency of 2. It has a valency of 2 means it can acquire 2 positive charges by donating or giving away 2 electrons. Okay, that is the quality of a metal. A metal is more electropositive. A metal can donate electrons. Now this is something we discussed in our earlier videos. So now what happens is lead is now ready to give 2 electrons. And those 2 electrons should be accepted by a nonmetal, which has the capacity to accept electrons and maintain them in the nonmetals. They can accept and it can maintain a covalent bond. So either it's an ionic bond or a covalent bond, but whatever it is, the nonmetal can accept the electrons. Now those 2 electrons which are donated by lead is accepted by 2 atoms of chlorine, because chlorine can accept only 1 electron. It cannot accept more. It can accept only 1 electron. So we need 2 chlorine atoms to accept the 2 electrons that are donated by or given away by the lead, and lead chloride is formed. And the 2 hydrogen ions react with the nitrate group, NO3, the nitrate group, and it forms nitric acid, which is simple to understand. Okay. Since the ions in the reactant side gets interchanged, this is an example of double displacement. Okay, let's move to the next. Identify the substances that are oxidized and substances that are reduced. Okay, sodium plus oxygen gives sodium oxide. Of course, sodium is oxidized. Copper oxide plus hydrogen gives copper plus H2O. Now this is quite not so simple. CuO loses oxygen, so it gets reduced. And hydrogen gains oxygen, so it is oxidized. And oxygen gains hydrogen, so it is again reduced. So the substances that are oxidized are hydrogen, which gains the oxygen, and sodium, which gains the oxygen. And the substances reduced are copper oxide, which loses the oxygen, and oxygen, which actually gains hydrogen. Let us meet in the next section, where we will discuss the exercises. Thank you.